Now let's see operations on real numbers. Basic operations are addition, subtraction, multiplication and division. The following examples show the operations using rational numbers. For all these types of operation, the result is also a rational number. But what happens if we operate two irrational numbers? Let's find out. Add root 2 and root 2, we get 2 root 2, which is an irrational number. Add root 3 and minus root 3, we get 0, which is rational. Subtract root 2 from root 2, we get 0, which is rational. Subtract root 2 from root 3, we get an irrational number. Multiply root 2 by root 2, we get 2, which is rational. Multiply root 2 by root 3, we get root 6, which is irrational. Divide root 2 by root 2, we get 1, which is rational. Divide root 2 by root 3, we get root 2 by 3, which is irrational. So we can conclude that if we add or subtract, multiply or divide between two irrational numbers, then the result is either rational or irrational. Now let's see what happens if we operate one rational number and one irrational number. 2 plus root 2, 3 minus root 2, 2 into root 2 and 3 by root 2. All these are irrational numbers. So we can conclude that if we add, subtract, multiply or divide one rational number and one irrational number, then the result is irrational. Just like rational numbers, irrational numbers are also commutative, associative and distributive for addition and multiplication. Let A, B, C and D be positive real numbers. Then these are the identities related to square root. Root of AB equals root A into root B. Root of A by B equals root A by root B. Root A plus root B into root A minus root B equals A minus B. A plus root B into A minus root B equals A square minus B. Root A plus root B into root C plus root D equals root AC plus root AD plus root BC plus root BD. Root A plus root B the whole square equals A plus 2 root AB plus B. Using these identities, we can operate several expressions of irrational numbers. We have the law of exponents for natural numbers A, M and N, where A is the base and M and N are exponents. A raised to M into A raised to N equals A raised to M plus N. A raised to M divided by A raised to N equals A raised to M minus N. A raised to M whole raised to N equals A raised to M N. A raised to M into B raised to M equals A into B whole raised to M. A raised to 0 equals 1. A raised to M by B raised to M equals A by B whole raised to M. Consider the identity B, that is A raised to M divided by A raised to N equals A raised to M minus N. Now let M equals 0. A raised to 0 by A raised to N will be equal to A raised to 0 minus N. Since A raised to 0 equals 1, then 1 by A raised to N equals A raised to minus N. This identity can be used for negative exponents. What if the exponents are rational numbers, that is in P by Q form? For example, 4 raised to 3 by 2. For this, we have a new identity, that is nth root of A equals A raised to 1 by N, where A is a real number and A greater than 0 and N is an integer. For example, cube root of 2 equals 2 raised to 1 by 3. Now what about 4 raised to 3 by 2? 4 raised to 3 by 2 equals 4 raised to 1 by 2 raised to 3, which is 2 raised to 3, which is equal to 8. It can also be written as 4 raised to 3 by 2 equals 4 raised to 3 raised to 1 by 2, which is equal to 64 raised to 1 by 2, which is 8. So we can say that A raised to m by n equals nth root of A whole raised to m or nth root of a raised to m, where a is a real number, a greater than 0, m and n are integers and n greater than 0. So we can conclude that the following laws of exponents can be used for real numbers a and b greater than 0 and m and n integers.